All right, so let's talk a minute about our special cases because while you're busy solving inequalities, remembering your rule, there's also going to be some special cases that may come up. Now, they should be easy to recognize because one of the big warning signs is going to be that your variable is going to disappear. It's going to cancel out somehow. So when that variable cancels out, you're left with two options. Those options are either it's going to be an equivalent inequality or a no solution inequality. Okay, so this is the type of inequality that you're going to have. So when we talk about the equivalent inequality, what I want you to write down, equivalent means everything is the same. So an equivalent inequality means that your solution will be all real numbers. Okay? So if I was to ask you to graph that solution, you would just graph a number line. Everything is included, positive, negative, to the left, to the right. Every single number is a solution for that inequality. So how will you know if it's an equivalent solution or an equivalent inequality? Here's what you'll write down. This happens, an inequivalent inequality happens when an inequality is true. And I'm going to put that in capital letters. You put it in capital letters, and then why don't you go ahead and underline it. So remember, your variables are going to factor out, cancel out somehow. You're going to be left with a number on the left side and a number on the right side of your inequality. You're going to have to look at that inequality and tell me if it's true or not. If that inequality is true, that means that any number you put in for that variable that canceled out, it's always going to be a true inequality. Any number. So that means your solution is an infinite number of numbers. So your solution is all real numbers. Any number that you pick, big, small, little, negative, positive, decimal, what have you, would give you a true inequality. Okay, so that's equivalent inequalities. The no solution inequalities is sort of like the opposite. This is when obviously there is no solution. Okay, this occurs, or we'll say this happens when an inequality is false. Okay, capital letters, underline. Now, remember, you're going to know that you're dealing with a special case when your variables somehow cancel out. Once your variables cancel out, you simplify it down to one number on the left side and one number on the right side of your inequality. I hope you guys are listening. All right? You will look at this inequality and determine whether it's true or false. If your inequality is false, what that means is there is no number that you could put. There isn't a single number that you could put in as that variable, as a value for that variable that would give you a true statement. So that means there's no solution. So if I was to ask you to graph that, you couldn't. There's nothing to graph. Your line wouldn't go to the left or the right. Wouldn't be open, closed, circle, nothing. There is no number that would be a solution for that inequality. It happens every once in a while. So what you're going to have to do is to look out for these. In the next video, we're going to do example 2 and practice how you determine whether you have an equivalent